Okay, this is a short demonstration of how to measure voltage or potential differences with our multimeter. When we want to measure voltages, we don't actually have to modify our circuit in any way. We just have to connect the voltmeter to our circuit to measure the voltage across the component that we're interested in. So I have a simple circuit here. It's just a resistor connected to a AA battery. The circuit is working regardless of whether or not I'm actually taking a measurement. Now, it doesn't take long for the wires in our circuit to get mixed up and make the connections difficult to see. So we use a circuit diagram to illustrate how the components are connected together. So this is a circuit diagram that represents the circuit that I have. It's just a single resistor connected to a single battery. To measure the voltage across the resistor, we need to connect a voltmeter in parallel with the resistor. So the circuit diagram should look like this. Now, it is absolutely critical that you switch your multimeter to DCV before you connect it to the circuit. If you connect the multimeter to the circuit in parallel with the resistor and have it set to DCA, then you're going to get a large current through the multimeter and you can burn up the meter's internal fuse. And if this happens, you're going to have to replace that fuse in order to measure the current again. And the meter comes with one extra fuse. So you can basically do this once and replace the fuse. If you do it again, you're going to have to find another fuse. So we set the dial to DCV before we connect it to our circuit. And then we just connect the multimeter to our circuit in parallel with the resistor by connecting one probe to each side of the resistor. If we look at the circuit diagram that we need to create, we see that it has two junctions, just like our circuit. Okay, so now we want to measure the voltage as accurately as we can, so we'll have to find the lowest max range that can measure the voltage, just like we did when we were measuring the resistance in the previous video. If you don't know what I'm talking about, then you just need to watch the video about measuring resistance. Notice that the voltage is actually being reported as a negative number here in my case, and this is just because I have my black lead connected to the positive side of the battery and I have my red lead connected to the negative side of the battery. If I swapped these two leads, then it would report a positive voltage, so that's not necessarily important. So let's start dialing the max range down until we find the smallest one that can measure our voltage. The first range says 1,000 on the dial, so it can measure up to 1,000 volts, and it displays a value that has units of volts. The measurement would be 1 plus or minus 1 volt. Again, the resistance measurement video discusses how we determine the uncertainty for our meter. So if I switch to the 200 setting, I get a measurement of 1.6 plus or minus 0.1 volts. The 20 setting gives 1.61 plus or minus 0.01 volts. The 2000 M setting gives 1612, and this is going to have units of millivolts because the units have changed. We see that the setting on the dial says 2000 M, and that M means milli. And finally, the 200 M setting shows that the measurement is out of range. So our voltage is larger than 200 millivolts, which means that we can't measure it with this setting. So we would go back to the 2000 M setting, and we would take 1612 plus or minus 1 millivolts, or 1.612 plus or minus 0.001 volts as the measurement.